Good evening, ma'am. Myself Bhuvaneshwari Jain. I am from 3rd SEM CSE department. As you give us a assignment topics, I have chosen the FCFS as it is first come first serve. We have introduction, objective, problem statement, experimental setup, implementation, observation of the output, comparison evaluation, application, and last conclusion. In introduction, as operating system scheduling, CPU scheduling decides which ready process runs on the CPU next. It affects waiting time, turnaround time, response time, and overall system behavior. I have chosen FCFS. It is a non-preemptive. Once the process starts, it runs until the completion. As we have the 4 processes, it is a first come first serve. It completes the process 1, next process 2, and until the last process. Scheduling order is by arrival time 0, 1, 2, 3, or it may be all the zeros. Simple, low overhead, but can suffer from conveyor effect. Objective of the assignment: design and implement a working FCFS stimulator that supports dynamic arrival time and bus time. Compare result and discuss whether FCFS is suitable for real-time system. Objective: the goal is to stimulate FCFS scheduling with dynamic arrival and bus time. To compare essential performance matrices such as waiting time, turnaround time, response time, contact switches, and CPU utilization. Waiting time we will calculate, turnaround time we will calculate, and in our syllabus we have completion time to calculate the turnaround time. To visualize process execution using Gantt chart. To compare performance across multiple datasets, to analyze and conclude whether FCFS is suitable for real-time system. These are the objectives we are facing in this FCFS. Problem statement: modern operating system requires efficient CPU scheduling techniques to manage multiple processes. FCFS being a simplest scheduling method, it is the first method we are calculating. Execute processes in the order of arrival without preemptive. However, its behavior under different workload must be analyzed to understand how arrival pattern affect waiting time, how bus time variations impact turnaround time, when FCFS suffers from a conveyor effect, whether FCFS can meet deadlines necessary for real-time applications. These are the problems we are facing. Thus, the problem addresses in the assignment is to design a functional FCFS scheduling stimulator and evaluate its performance on multiple datasets to determine its successibility for real-time system. Experimental setup: we have used Python tools as Jupyter style execution, Matplotlib for the Gantt chart, Pandas for tabular. Output: we have a 3 dataset output. First one, simple staggered arrivals, means as normal processes which arrives on 0, 2, 4, 6. The bus time is 5, 3, 1, 2 for the process 1, 2, 3, 4. Data set, we have all the arrival times as 0. Bus time 4, 3, 1, 2. For the data set 3, the ideal gaps and varied burst. They are the ideal gaps in between them. Arrival time is 0, 5, 6, 12. Bus time is 3, 4, 2, 5. These are the three main datasets I am using here. Implementation. In implementation, we have algorithm, code, and flowchart. Here I am not including the code as it is from my side, and algorithm. First, sort the process by arrival time. In the ascending order, you can sort it. Stimulate time from the first arrival forward. If CPU time is less than next arrival, insert ideal segment until arrival. Start the next process at current time. Process run to completion. Record start time, completion time. Third, compute per process matrices. Waiting is equals to start minus arrival. Turn around is equals to completion minus arrival. Response is equals to start minus arrival. Count. Context switches as a number of times the CPU switches between different segments. Fifth, compute CPU utilization, bus time or completion time minus first arrival into 100%. The flowchart. Flowchart is for representation, visual representation. Here start or load the process list, sort by arrival, time is equals to first arrival time, pick next process. No more processes means we can end the CPU scheduling. If is there any processes, we can go to the next process. Time is less than arrival, ideal segment. If no, run process, non-preemptive. Start or end the record, update matrices, and next loop, next process, and then run process, record, update as it is. For the last process, until the last process, it will execute in a loop. Observation, or we can say it as a output result. I executed the stimulator for the three datasets as I told before. That's dataset 1, 2, 3. Below are the written per process tabular and matrices produced by the program. For dataset 1, as normal, we have taken the four processes P1, P2, P3, P4. Arrival time 0, 2, 4, 6. Bus time 5, 3, 1, 2. Here we have the starting time as 0, 5, 8 and 9. It completes over, we will take a completion time as where the processes end 5, 8, 9, 11. And the waiting time, how much time it takes to response 0, 3, 4, 3. Turnaround time is nothing but completion time minus arrival time 5, 6, 5, 5. Response, how much time taken to response 0, 3, 4, 3. As a result, we get average waiting time is 2.50, average turnaround time 5.25, average response time 2.50, contact switching is 3. CPU utilization in percentage, how much the CPU utilized the program or the processes, it's 100%. Gantt chart is saved. For dataset 2, we have again taken the four processes P1, P2, P3, P4. Arrival time as all as 0. It is dataset 2. Bus time 4, 3, 1, 2. Starting time 0, 4, 7, 8. Completion time 4, 7, 8, 10. Waiting time 0478. Turnaround time, completion time minus arrival time 47810. The response is 0478. At last we can find out the average waiting time 4.75, average turnaround time 7.25, average response time 4.75, context switching is 3, and CPU utilization also 100%. Gantt chart is saved. And last we have dataset 3. We taken a P1, P2, P3, P4, and arrival time 05612, bus time 3425, and starting time of P1 to P4 is 05912. Completion means ending time is 391117. Waiting time 0030. TAT turnaround time 3455. Response time 0030. As a result, we can get average waiting time is 0.75, average TAT time turnaround time is 4.25, average response time 0.75, contact switching is 5, CPU utilization is 82.35%. Gantt chart, here also it is saved the Gantt chart. These are the 3 data set, and with the result of the output I have said comparison evaluation, which is best and how it is taken. As I said, the data sets are 1, 2, 3, average waiting time, average TAT time, average response time, contact switching, CPU utilization. These are all, as I have already said, I have written it in a comparison evaluation like a table. And application batch process system, second simple embedded system, third print polar management, fourth file input and output queue handling, fifth customer service queues. As a conclusion, the FCFS scheduling algorithm is a straightforward, easy to implement, and ensures fairness by executing processes. FCFS suffers from high waiting time when many processes arise at the same time. It is heavily affected by the variations in bus time, leading to the conveyor effect. Response time increases significantly for the later process in the queue. Lack of preemptive makes FCFS unsuitable for real-time systems where deadlines and low latencies are critical. This is my assignment which I wrote, and these are the topics I have explained. Thank you.